Today we're going to look at section 5.4, factoring polynomials. Our objective is to be able to factor a polynomial completely by using the techniques of GCF, our trinomial factoring, difference of two squares, grouping, sum of two cubes, and difference of two cubes. So the techniques we're going to be using to factor our polynomials, well, our first three we've actually used before, are GCF factoring, okay, where we take out our greatest common factor, leaving us with our terms inside our parentheses. Our trinomial factoring, okay, where I try to break it down into its parts, its factors, so you can kind of see a little bit, where I have some lead coefficient of x squared, a lead coefficient for my x, and my constant. And if I look at it and break it down into its factors, I can see my two binomials that will multiply and expand back to my original, where if I multiplied and distributed my first, I get ab x squared. If I multiply my last terms, I get m times n. And if I multiply my first times my last, I get anx. Here I get bmx, which I can combine like terms to get my middle term. And we also have a difference of two squares, where we have a perfect square minus a perfect square, which could be broken down, for example, to a plus b and a minus b. But we're going to be talking about three new ways that we're going to factor our polynomials. And one is grouping, and this is really useful because we use this when we have four terms. And when we have four terms, if we can factor out and take a GCF out of the first two terms and take a GCF out of the second two terms, or some sort of factor, and we're left with two parentheses that are identical. If that is the case, this x plus c, for example, is now my new GCF. It's my new greatest common factor. Well, if I factor that out, I can be left with a plus b in my parentheses. And what I mean by that is this is my GCF. If I distribute it back, this would give me a times x plus c, which is what I started with. If I distribute the whole thing to my second term, I get b times x plus c, which is what we started with. And that's a technique we're going to be using quite a bit. We're also going to talk about sum of two cubes and difference of two cubes. We've talked about difference of two squares, where we have a perfect square minus a perfect square. Well, when we have cubes, it doesn't matter if we add the two or subtract the two. It's always going to factor down into a small parenthesis, a binomial, and a larger parenthesis with a trinomial. It's always going to be broken down into a cubed plus b cubed. If I just look at the a value and the b value, okay, I'm going to get a plus b times the quantity a squared minus a times b plus b squared. And anytime we square something, it's always positive. That's why this a squared is positive and the b squared is positive. When I have a difference of two cubes, the only thing that changes are our sign values. I still am going to concentrate on the a value and the b value, but now I'm subtracting the a and b in the first parentheses. Okay, here I was adding because I was the sum of two cubes. And then my a squared, my b squared, again, those are always positive. But now what I'm going to do is add a times b. If you notice here, I'm adding a times b, and it started off as a minus problem. Here I was subtracting ab, and it started off as a plus. It's always the opposite sign. So let's go through some examples. So our first one is 3x squared y cubed plus 6x y to the fourth minus 12x to the fourth y squared. We usually try to use our GCF. Try to take out anything common first. Makes it a lot easier. So if I look here, I have a 3, 6, and negative 12. I know I can take out a factor of 3. I have x squared, x to the first, x to the fourth. Well, if I look at my x's, the most I can take out is a factor of x to the first, and you don't have to write the 1. Y cubed, y to the fourth, y squared. Y squared is the largest factor of y's I can take out. Because I started with 1, 2, 3 separate terms, I should have 3 separate terms inside my parentheses. So 3 divided by 3 is 1. Okay, you don't have to write it, but I'm going to do that for our example. X squared divided by x is just an x. Y cubed divided by y squared is y. Okay, because when you factor out something, it's truly like doing a division. Okay, plus 2. X divided by x would just be 1, so I don't have to worry about writing that. And y to the fourth and y squared leaves me with y squared. Minus 12 divided by 3 is 4. X to the fourth, if I take out x to the first power, I'm left with x cubed, and I have no more y's, and this is what I'm left with. Okay? If I look inside, there's no other way I can factor this. This would be my final answer, and you can always distribute to see if you get back to your original answer. If you did, you know you at least didn't make an algebraic mistake. Our second example It does not have a GCF. There's nothing common I can pull out. And there are 3 terms, so this would be an example of one of my trinomial problems, which would factor down into 2 binomials. What you want to do is break this down into its factors. 6 is either 1 times 6 or 2 times 3. And this should be a review from what we did before. 7 is just 1 times 7. I find it's always easiest to deal with the one that only has one term or one set of factors. So I know to get this 7, I'm going to need a 1 and a 7. Okay. To get my 6x squared, I know I'm going to need some x's, and I don't know which values I'm going to use right now. And I know to get my 19x in the middle, the outside terms are going to get multiplied together, and the inside terms are going to get multiplied together. And I need to somehow get a 19x when I do that, a positive 19x. Well, let's start to look at what numbers I want to use. So I need to decide it's going to be 1 and 6, 6 and 1, 2 and 3, or a 3 and a 2. Okay, I need to go through things. And I know I need to get a 19. And you can go through a lot of different guess and check, but I know if I put a 3 here and a 2 here, here's going to give me a 2x. The outside's going to give me a 21x. Okay. Well, how could I get a positive 19? Well, I can get a positive 19 if the 21 is positive and the 2x is negative. So that means this top track has to be negative and the outside track has to be positive. And before I go on and assume that this is my correct answer, let's double check. Does 3x times 2x give me 6x squared? Yes. Does negative 1 and a positive 7 give me a negative 7? Yes. And I already double checked and checked to know that I get a 19x when I do my middle 2 terms and my outside terms. So 3x minus 1 times the quantity 2x plus 7 would be my final answer. Here's another example of a trinomial, but I should notice that there is a common term, common factor of 2, that I can take out first, which would leave me with x squared plus x minus 6. Okay. It's always best to do that first, especially when dealing with trinomials, because now what it leaves me with is another trinomial with smaller numbers, which might make it easier to factor. So now if I look at my inside trinomial, here's a 1, which my factors are 1 times 1. Here's a 6, which is 1 times 6, or 2 times 3. Now sometimes this will be able to factor on further, sometimes it won't, but you won't know unless you try. So I know I have a 2 on the outside. Let's see if this is my final answer or if I can go further. I know to get an x squared, I have a 1x and an x, a 1x. And now I need to decide, am I going to use a 1 and 6, 6 and 1, 2 and 3, or 3 and 2. So again, I know these multiply together and those. I know I need to get my middle term of a positive 1x in the middle. Well, I know if I use that 2 and a 3, I'm going to get a 2x in the inside and a 3x on the outside. How could I combine those to make a positive 1x? Well, I need a positive 3x and a negative 2x, which would mean the top track is negative, the outside track would be positive. So let's see if these 2 binomials will multiply to give me that trinomial if I expand it. X times x is x squared, negative 2 and a positive 3 is negative 6, and I already know the middle adds to give me 1. So my final answer, because it says factor completely, it just doesn't say just do any kind of factoring, you have to keep going until you cannot break it down any further, would be 2 times x minus 2 times x plus 3. Alright, let's look at this last, or this number 4. If I look, I do not have anything common. There's no GCF. But I notice I only have 2 terms, and I'm subtracting them. And let's see if I can break this down. If I look at x to the 4th, y to the 6th, I know that this is x squared squared. And I know y to the 6th is y cubed squared. And if I look at 36, I know that's 6 squared. And I know z squared can be written as z to the 1st squared. Because I can break down each of the individual terms into quantities squared, this is called a difference of 2 squares, which will factor down to two binomials. And all I'm going to do is take one of each of these pairs and put them in each parenthesis. So I know I need an x squared and a y cubed in each one, x squared and y cubed. I know if I look at my second part, I know I need a 6 and a z, 6 and a z. But I need to get a negative. When I multiply my first 2, There's my x fourth, y to the 6th. But when I multiply the last two, I get a 36z squared, but it needs to be a negative. So it means one has to be positive, one has to be negative to get my final answer. Now, if you notice, there is no middle term here, and the reason is because if I multiply the outside, I get a negative 6 x squared y cubed z. If I multiply the inside, I get a positive 6 x squared y cubed z. And those two terms will simplify out to 0, and that's why we don't have a middle term, and it's a binomial, two terms, not a trinomial. And that would be my final answer. If I look here, these will not be able to be broken down any further. All right, let's look at number 5. 5 is, I have two terms, so it's a binomial, but I cannot break each of these individually down to something squared. 32, there's lots of different factors, but nothing squared. But you should notice that there's a common factor of 2 that I could take out of each of these. And if I do that, I'm left with 16x squared minus 1. Now that I've factored out the 2, I can look here and I can actually break down 16 into 4 squared, x squared into x to the first squared, and 1 can be broken down into 1 squared. Because I can do that, I have to keep this 2. You can't lose any of your individual factors. I know now this smaller part is a difference of 2 squares. So I can put a 4x and a 4x. I know I get a 1 and a 1. And the only way I can make it negative is 1 is positive, 1 is negative. I can't break down these any further, so this would be factored completely. So that's how we use GCF and difference of 2 squares together. So now we're getting to some of our new stuff. This is an example of one that I would try to use grouping for. What I mean by grouping is I'm going to look at the first two as a smaller problem, and then the last two as a smaller problem. Now, it doesn't always have to be the first two and the last two. Usually in our class, AAT 300, we keep it in order for you to make it a little bit easier. But some of the more advanced problems, or the honors classes, might mix these up where you can't factor by grouping how it looks. You have to do a little manipulation first. But we're going to keep it pretty straightforward right now. So if I look at the first two as a tiny problem, I can see that there's an x squared I can factor out. And if I factor out x squared, I'm left with x minus 2. Okay. And again, this is just one continuation, but I'm just going to break it down into smaller parts. If I look here, I can see that I can factor out a negative 4, which would leave me with an x minus 2. Now you might have said, well, I could have factored out just a positive 4. But if I factored out a positive 4, that would leave me with negative x plus a 2. And these parentheses wouldn't be identical. Now the reason that's important that they're identical is because now if I look, this is common to both parts. So what I'm going to do is factor out an x minus 2. And if I factor out an x minus 2, that's going to leave me with this x squared and this minus 4. Okay. Because if I distribute, I'm going to get an x squared times x minus 2 and a negative 4 times x minus 2. Okay. And then I get back to my original. And this, if I distributed my x squared to both and my negative 4, I'd get back to the original. That's the biggest thing you have to be careful with factoring, is that you don't lose any terms. I can't square things, I can't take the square root, but I can multiply to get back to my original. Alright, so now, okay, I look here, I have nothing in common. It's not a difference of 2 squares because it's not a minus sign. I don't have 4 things to do grouping. There's not 3 things to do a trinomial, so what is this? Well, I can break this down into something cubed. So this is x times x times x, so x to the first cubed. This is 2 times 2 times 2. So now I have the sum of 2 cubes. So how do we factor that? Well, what I do is I break it down first just to give me an idea of what my a value and my b value would be if I look at my formula. And this is going to be an x plus 2. And the reason it's a plus sign is because it's a sum. Now I'm going to write my second parenthesis is going to have a trinomial. It's the first part squared, so x times x is x squared. Okay. The middle term is always the opposite sign, so I'm going to put a minus sign, and then these two multiply together. Well, that's 2x. And then we're always going to take the last one and square it. And anything squared is always positive, so that's going to be plus 4. This will not be able to be factored anymore. Students always make the mistake of trying to factor this, and they'll make up something, but then they'll never check to make sure that if I expand it, I get back to my original. And since it will never work, The students who try to go on further are always wrong. So please just stop right here because that's what the formula tells us to do. Let's look at another one. This one I made a little bit more complicated, and you're going to start to get used to the numbers that are cubed, perfect cubes. 64 is 4 times 4 times 4. X to the 6 is x squared times x squared times x squared. Okay. 27 is 3 times 3 times 3. And y cubed is y times y times y. Now that I've broken it down, my first parenthesis, okay, is going to be one of each of my first terms. So this, my first term breaks down to a 4x squared cubed. My last term, okay, I'm going to keep the plus sign, is 3 times y. If I cube this or multiply by itself 3 times, I get back to 64x to the 6th. And likewise, 3y cubed gives me back to 27y to the 3rd. So now I need to come up with my trinomial. Remember, you take the first part, which is probably easier to see it in our parentheses, 4x squared, and I square it. So if I take 4x squared and I actually square it, that means 4x squared times 4x squared. That gets me 16x to the 4th power. And if you can't do that correctly by writing it out here, physically write out 4x squared times 4x squared. Maybe that'll keep you from making mistakes. Now, my middle term is always the opposite sign, so I'm going to put a minus sign. And then all I do is multiply these two together. Well, 4x squared times 3y is going to give me a 12x squared y. And in my last term, I'm going to take the last part, 3y, and square it. Remember again, that's just 3y times 3y, which is a positive 9y squared. And remember, as soon as we do this, we're done. Okay? And that's as far as I can go. And that's how you factor a sum of two cubes. But what if I don't have a sum? What if I have a difference? Okay, all it is a couple sign changes. This is 8 is 2 times 2 times 2. X cubed is x times x times x. And this always throws people, but 1 again is just 1 times 1 times 1. So I'm going to get my smaller parentheses. I'm going to look at my first term. That's 2x times 2x times 2x. Get me back to 8x cubed. Minus, and the reason it's minus because this is a difference now. And this is 1 times 1 times 1. Okay, same process. To get this, I'm going to take my first term and multiply it by itself. So 2x times 2x is 4x squared. To find my middle term, I'm going to do the opposite sign, so it's to be a positive. And now I just multiply the two terms. What's 2x times 1? Just 2x. And now how do I get the last term? You just take the last, or b value, multiply by itself. 1 times 1 is a positive 1. And that is my final answer. And that is factored completely. Alright, so what if I make it a little bit trickier? It doesn't matter where the variables, if it's first or second. Okay, you just break it down the same way. 125 is 5 times 5 times 5. 27 is 3 times 3 times 3. And y to the 12th is y to the 4th times y to the 4th. So now I'm going to get my smaller parenthesis. I take my a value from my formula, which is just 5, minus, and here I need a 3y to the 4th. Again, what goes in this parentheses is what you would have to cube to get back to the original. So 5 times 5 times 5 gets me 125. 3y to the 4th times 3y to the 4th times 3y to the 4th gets me back to 27y to the 12th. Now I'm going to write my larger parenthesis. I just take the first term and multiply by itself, which is 25. I do the opposite sign, so this is a positive, and then I multiply the first, 5, times the b value, the second, 3y to the 4th. This gets me 15y to the 4th. And to get the last term, it's just 3y to the 4th times 3y to the 4th. Again, this is always going to be positive because we're squaring something. 3 times 3 is 9. Y to the 4th times y to the 4th. Remember, you add exponents. Gets me y to the 8th. So my final answer would look like this. So let's put them together a little bit. Okay, I see this minus sign, and it kind of looks like it might be different to two squares because this is 6 times 6, but x to the 7th is nothing times itself. So let's see, maybe this is a difference of two cubes, but there's nothing multiplied by itself to give me 36, or at least nothing by itself 3 times. So that's not going to work. So let's go back to some of the first things we did. So one of the first things we talked about was a GCF. So let's look. Is there anything common I can pull out? Well, if I look at 36 and 441, and the 441 might be a little bit more difficult, but I can pull out a factor of 9. And if I notice this has x to the 7th, this is x to the 5th, that means I can take out the greatest number of x's I can take out is x to the 5th. And now if I do that, I'm left with 4x squared. 9 goes into 441 times 49 times, but there's no more x's. And again, I can double check if I distribute my 9x to the 5th to both these terms, I'll get back to what I started with. Now you always want to look inside your parentheses and think, is this something that can factor down further? Well, it's a minus sign. There's only 2 terms, so that means it's either going to be a difference of 2 squares or a difference of 2 cubes. And because this is x squared, I'm going to try the difference of 2 squares. I know 4 is 2 squared. X squared is x to the first squared. And 49 is 7 squared. And because I was able to break everything down, I know this is a difference of 2 squares. You always have to keep your first factor. Again, you can't lose anything. My difference of 2 squares is going to factor down to 2 parentheses. To get 4x squared, it's 2x times a 2x, so that's going to be in the front of my parentheses. To get 49, it's 7 times 7. But it's a negative 49, so one has to be positive, one has to be negative. Neither of those can factor down any further, and that would be my final answer. And let's look at our very last one. If I look here, okay, x to the 5th minus 16x cubed minus 8x squared plus 128. If I look, there's not x's in all the terms, all 4 terms, so I can't use that as a GCF. And my lead coefficient here is a 1, so the largest number I could pull out of any of them is a 1, so I don't want to deal with that. So that's why I'm going to look at the first 2, okay, and then I'm going to look at the last 2 terms separately as 2 smaller problems. If I look at the first one, I know I can factor out an x cubed, which leaves me with an x squared minus 4. Okay. If I look at the second 2, now, to help you out, do you see how you have an x squared minus 4? So that means I want a positive minus our value. So that means I want a positive in front. So that means I'm going to try to factor out a negative 8. If I do that, I'm left with x squared minus, let's look at our last example. I have my 4 terms here, so it's going to be a factor by grouping, but let's first check to see if there's a GCF. Now usually I don't prefer to take out the GCF first if it exists for grouping because sometimes the number of parentheses gets confusing. So whenever I see 4 terms, I go straight to grouping. Okay? And this one didn't have a GCF anyways, but just as a little technique that might help you out, if you see 4 terms, go straight to grouping, then try any GCF later if possible. So I'm going to look at the first 2. Okay. I could pull out an x cubed, which leaves me with an x squared minus 16. Okay. When I look at the next 2 terms, my goal, if I'm using factor by grouping, is to get the parenthesis to be exactly the same. So if I factor out a negative 8, I'm left with an x squared minus 16, which works out pretty nice. I look and I see that my parentheses are exactly the same. Okay, so that means this is now my new common factor. So I'm going to pull out an x squared minus 16, okay, which would leave me with an x cubed minus 8. Okay, so, and again, if I take this full term and distribute it, I'm going to get back to my 2 terms I had above it. But if I looked here, x squared minus 16, that should look familiar. This is a difference of 2 squares. I know x squared minus 16 can be broken down to an x plus 4 and an x minus 4. Okay? Because this was x times x, 4 times 4. If I look here, this isn't a difference of 2 squares because I have that x cubed, but I can factor it down to a difference of 2 cubes because x cubed is x times x times x. Negative 8 is 2 times 2 times 2, so I'm going to have an x minus 2 for my first parenthesis. My second parenthesis I'm going to get by taking the first term and multiplying it by itself, so x times x is x squared. My next term is always the opposite symbol, so it's going to be now a positive. X times 2 is 2x. And my last is always by squaring the last term. 2 times 2 is a positive 4. And we know that with a trinomial, this is as far as you can go. So this original problem, which was a grouping problem, not only had grouping, okay, grouping is just a whole bunch of GCF problems, but then it also had a difference of 2 squares and a difference of 2 cubes. So that's a way where you can make a more complicated problem and put it all together. So if you feel a little bit better about being able to factor polynomials completely using GCF, trinomial, difference of 2 squares, grouping, sum of 2 cubes, and difference of 2 cubes right now.